Thank you for the nice introduction. Okay, so uh, I have a degree in physics, and I have also did my PhD in physics, and it was still uh, about programming and simulation in C++. But I have taken some machine learning classes. That was classic machine learning. That was the thing at the time. But since then, I've played around with some GPU programming in Python. You can ask about it. It's not today's topic, so I'm not going to talk about that in this presentation. But I'm going to talk about neural networks and how to use them in the research. So I give you an insight in the work of the AI ambassadors in the different Harran institutions. Okay, so how does this program work? That Harran recognizes that AI is everywhere and we need to embrace it, so we not lag behind in our research. So rather, we should use these tools which are already available to excel in our own fields of research. Therefore, they created a program called AI for Science, which was renamed AI for Impact to even cover more a broader scope, and with the aim that all researchers should be in possession of some basic skills concerning AI. Okay, within this program, Hanren provides us with experts who are a technical support team for new project who evaluate requests, whether we want to use when we want to use AI in our specific research question, they do a feasibility check and then provide technical support in programming and so on. And to reach those experts, they have named AI ambassadors for all of the 100 institutes who link these experts to the researchers of the institute and communicate and facilitate the communication between them. So as AI ambassadors, we organize events like journal clubs or seminars and talks about AI. We spread information about available technologies on the web and within Hanran. And also, when some researchers have new needs or opinions, we forward those to the headquarters. Okay, so that's about the network. And now let's move to some specific applications. In this talk, I'm going to cover some basics of large language models. I will give some definitions. And also, I mentioned generative AI as a topic, but they are somewhat interleaved. We will see some use cases for them. And finally, I'm going to talk about physics-informed neural networks, which were mentioned already in the talk of Peter Kovács. Okay, so let's move on and see what a large language model is and how it fits into the research tasks. In the scientific picture, a large language model is part of the artificial intelligence, inside which we find machine learning, and within machine learning, we have deep neural networks. A specialization of them are transformer models, and within them, there are large language models, which are language models, and some of them are used in generative AI applications. So that's nice, and everyone understands that. We have another aspect of that, that is the legal aspect. So how this European Union's AI Act approaches to these systems. So AI is a computer system that makes decisions, has autonomy. So that's an AI system. When we look at it, that pretty much covers everything that is classical machine learning as well. So they are prepared for everything. This new AI can apply to classical machine learning already, but by having autonomy, the legal actors had some different opinion. Okay, so that covers pretty much every system that we can use for decision making. And we have this other circle, which means they can adapt. Wait a minute, what? Adapt? No way. Current large language models have fixed weights when deployed, so they cannot adapt. What did they have in mind? Of course, when we discussed it a bit, we concluded that during the training they can adapt. So that therefore every large language model is considered as an agent that can adapt, even if it cannot adapt during the deployment. So it reacts to our prompts. So that's the legal view of AIs. So when you sell or use AI in your products or make an AI service available to everyone, then you have to take care about the European Union's AI Act. As researchers, we are a bit exempt from that if we use it for our own research on. Okay, so we have seen what large language models are and how they fit into this hierarchy. Probably you know already that they are not a magical thing. They are deep neural network trained on a large corpus, and they are good at typical tasks. So whatever they have seen, they are good at. We cannot expect from them logical reasoning or understanding of the text they process. They are just text prediction tools, but they can look like systems that do reasoning and provide us with chains of thought that resemble human reasoning. They can be instructed. So there was a specialty of prompt engineering in the past, which is not relevant today because they have evolved so much that they understand even badly formulated requests. Okay, but if you want to increase the success of your query, then the instruction shall be clear, specific, describe all important aspects, context, use examples. The AI can take roles, so a narrative how they present the response. But again, from the legal point of view, they cannot be a co-author because they cannot take responsibility. They are just a tool in our research. And they are so rapidly developing that whatever we see today may be not relevant tomorrow. They can surpass it. Some examples for those systems are used in literature review. I have some specific recommendations. So everyone uses ChatGPT, but it's just a text prediction tool. It can make up references when we ask for scientific questions. They can search the web, and one that is especially good, particularly good at that is Perplexity, which always searches the web, gathers resources, summarizes them for us. So for each phrase that it puts on the output, they have references for where it has read it. It has advantages and drawbacks. For example, with a friend, we tried the question, is human kinesiology a real scientific domain? And in Hungarian, we get results from NL and gyakorikérdések.hu, which are like user forums and not trusted at all. When we pose the same question in English, then we got resources from the American National Institute of Health and other reliable resources. So questions and language matters for these as well. And there were some promotions for users of the T mobile phone company to use a coupon to activate that. There is another one which is more related to scientific writing and tasks, which is called SciSpace, which is organized around the idea that you should be able to do literature reviews. So it's like the deep research in other AI agents as well, but specifically trained for handling citation databases, retrieving papers, processing those PDFs and summarizing them. We will see further features of them as on the next slides. But there is another application. So far we have discussed generative AI, but sometimes they are just used for embedding. There are models like BERT, which is a bidirectional encoder representation, which only map our thoughts, our text, to a latent space of high dimensions, which somehow captures the context and the meaning of the text. And they can be used for grouping or clustering ideas, papers. So I have brought you two examples for that. Research Rabbit and connected papers, which help us to find the context of a paper. So if we read a paper that is interesting for us, we can ask the question, what papers refer to that, or what paper this source references, and put them on a graph, and somehow, using AI, filter out the most important papers among all of those. So we don't have to go through thousands of papers. It does that for us. And there is a Hungarian version for that as well, which is a publication map of the derived from the MTMT database for the 100 institutes. It's a nomic atlas, which uses a similar embedding in high dimension, which is then projected to two dimensions, and we can see that it identifies research fields. We can color the publications by institutions and see which institute do overlapping or similar or research in similar fields as well. I recommend that to check that out. So now we have covered how we get input from these generative AI models, but when we want to produce some new text output, then there are some important questions. Even when reviewing literature, those questions may arise, but not that significantly. So whether I shall use ChatGPT for my research or not. So I have to pose a question first, that does it matter that the output is true, that ChatGPT gets to me? If it doesn't matter, then it's safe to use. Can you give us some scenarios when it's not relevant whether the output is true? For example, if I request for a haiku or a poem or whatever to generate a picture of a cat doing something, then it's not relevant whether it's true. I want just to amuse my friends. But in science, usually, yes, it matters whether the output is true. So we have to verify somehow. The next question is whether I have the expertise to check whether the output is true. So I can speed up my tasks with generative AI if I can verify the output. And the final question before I publish my paper is whether I'm willing to take responsibility for whatever output I get from ChatGPT when publishing. So when I produce a paper, I take the full responsibility as declared previously. So ChatGPT is technically not a co-author, but a tool, and the responsibility is to the driver, to us users. Okay, when you use ChatGPT, there is an important piece of advice. When you go to settings, you can turn out this improve the model for everyone. In that way, even with a free account, they promise not to use your queries for improving the model. So if you deal with somewhat sensitive information like planning your next paper and you don't want to end those thoughts up in some databases, then please turn this off, and they promise not to collect that data. Okay, when you do a prompt, there are some general advices to follow, that you can give the large language model generative AI personality, in which style you expect the response, for example, explain as an expert, talking to a child, that you can pose the question which should include all important aspects, and you can also give a decorator how you want to see it. For example, if you want a piece of code, then you want every line commented or in some specific paradigm. And when using those tools, it's not really useful to be polite. If you are put please on the end to add other to the request, it will respond, yes, sir, here is a revised version. So it will mimic your style, but it's just burning electricity and resources by processing more tokens that way. Okay, if you have more training data, then you can expect better performance, as we have seen. If you ask a question in English and concerning Python programming, then you get better results than asking Fortran questions in Hungarian. Okay, if you provide context, then you restrict the creativity or the temperature or the randomness of these models to focus on the task you want to solve. You can guide the model with examples, and nowadays the models automatically evaluate whether it's a complex task, and they can break down it into subtasks and play as an agentic framework that they plan the task with subtasks, solve those subtasks, then another agent evaluates whether it's a good solution, whether it seems trustworthy, and summarizes that before providing the output to you. A model called DeepSeek does especially that with a mixture of experts and reasoning, but you can ask such things from ChatGPT and Perplexity as well with that switch of deep research or deep uh, question answering. They will put more effort into finding out the answer. Okay. If you do not trust those public entities, then you have a similar system installed at Stucky, which is the Hanran generative AI platform, which uses this free WebUI. There are free models installed into it. You can have API access to it as well. And in that way, your data does not leave the Hanran cloud. But moreover, there is an important aspect that Hanran got some credits from OpenAI. So if you have a important research subject where you want to specifically use the models of OpenAI, then you can opt for some credits that Hanran has for your research. Okay. These open models can use multimodal input, search the web, or use PDFs for generating output. That's all included into that. But if you don't even trust Hanran, then you always has the option to run those models on your local computer. Okay, you may need a GPU because on CPU it's quite slow, but still you can try it. And there are smaller models with like 1 billion parameters, which can run on basic GPUs as well. And it's really easy to do. So nowadays there is no barrier for that. I think only a few people know that you can download and install Ollama, which is ready for all major platforms like Unix, Windows, install it, run a model from command line or access from the API from a Python script. And in this way, we can process even pictures. So I download a picture from the URL, I save it on my local machine, and if I provide it as a special tag in my query, then it will process it. There are multimodal versions that can process image and describe what's inside it. So that's important to note that you have all the possibilities. When you want to use these models for scientific writing, I turn back a bit to SciSpace, which comes as a bundle. You can chat with PDFs, do a literature review, use AI writer, find crop topics, novelty. You can generate citations in specific format, extra data, or even use its features for detecting AI in other text, so the use of AI for generating text. So these tools exist. There are alternatives as well. And even with a single line query, you get already a structure for your proposed paper. So these tools are there. And if you don't use them, there is a risk that you can't catch up with others who embrace those tools. There is another important aspect. For coding, you can use GitHub Copilot. Now it has a free version with some quota available for everyone. So there is a limit on questions or code completions that you can ask for, but you can also try out its agentic workflow where you can ask it to process complex tasks with using steps. So the difference between those general large language models and GitHub Copilot is that it's specifically trained on programming tasks, and it can see your repository as a context. It has advantages. So if you use it as a pair programmer, then it acts as a newly come programmer you just hired, but who has taken all the possible boot camps, but is already familiar with the company's code base. So it is ready to complete that code base or replicate errors that are present in the code base as well. Here, the same specifics apply as well, that you are the driver, you are the navigator who has to be clever, plan the tasks, and ask the correct questions. And the AI is the driver who actually writes the code, and you have to check that code. Okay, there are some novelties in GitHub Copilot I've spoken about, that there are new features you can try out. It can work as agents for tracking issues, making plans, writing text, or documentation. It can iterate those tasks in the background. So while you are doing other stuff, it can work in the background for you. Same way you can turn off using your code in training the models for GitHub as well. Here I have some ideas. You can check the slides later what to do with GitHub Copilot. And there is one more thing that I would like to talk about. So when we are not just using these generative AI models for general tasks, but using deep neural networks for specifically physics-related tasks, that can be called a physics-informed neural network, which responds to a specific task description. So we started a journal club this year to read some review papers and some specific applications about physics-informed neural networks and learn what those are. So feel free to join if you are interested. Those journal club events are broadcast over Zoom. So what is a physics-informed neural networks? It's the typical settings for solving the task where we have some measurement data and also some understanding of the underlying physics. So we know about the physics laws in the form of partial differential equations or other forms, and we want the solution to a specific differential equation as a function of the time, and we can build a network which does just that. So that is the task formulation, and into the network we put the following loss. There are parts of the loss which correspond to fulfilling the differential equation. So when the solution is defined as time derivative of u is equal to some differential operator acting on the current state of the system, we bring that equations to zero equal the sum of those two terms. That will be the right-hand side, so that we can use it in the loss. When this term is close to zero, that it means that the solution u, fulfills the differential equation that we have put inside it. And we have two other terms, some boundary conditions related to the solution, and some data which is measured inside the domain. And difference from those measurements or boundary conditions are generally put into the loss with this squared loss formalism, but that can be changed as well. And the advantage of this formulation is that in most systems there is automatic differentiation. That means that you can provide the differential equation and it takes care of calculating the derivatives. No need for you to calculate them analytically. It can specify the time derivatives for boundary conditions. So the network looks like this. That is the input, the state and the time. It goes inside. We calculate the derivatives which appear in those terms. We sum the loss, and we do a specific training for the with the common methods. The neural networks act as a universal approximator, but for extrapolation they are poor. Therefore, we included the physical laws, which improves the extrapolation and act as a regularizer. They can be trained on GPU, and they are used in very different field of applications. There are some challenges, which are the optimal network architectures, activation function, how to train them, and also in this formalism, we train the network to solve for a specific initial and boundary conditions. So we get a solution complementing our data. But there are some attempts to handle multiple initial conditions as well, so to get a general solution to our problem. So thank you for your attention. I think my time is over.
Thank you very much, Marci. So first of all, I would like to just emphasize that Marci is available at the Wigner event for broader audience, and you can find him. You can also join the Journal Club, what we have, and Ferenc Csikor is the other party in the business.
Yes,
And
there are two ambassadors at Wigner. So every research institute got a number of ambassadors proportional to its size.
questions. Thank you for the overview. I have some questions regarding the first part of the talk, namely, you were talking mostly about ChatGPT, right?
Mostly, but I have brought you other examples as well.
Yeah. So if we look outside, there are basically an LLM offering from all of the large companies, and there are many other minor ones. And the question arises: what differences are between them for different tasks? For example, I'm interested in generating code, or interested in some mathematical derivation, or interested in facts. I would like to check a fact. Is it true or not, or what is the state of art in some topic? And they might not perform the same way or the same level, or they may have different failure cases. The first question of mine is there anyone who is doing some deep comparison, some benchmarking, setting up private test sets for the publicly available offerings, such that there is a external party who can give you guidance on which model is better for which task? And the other part of my question is specifically for Hungarian language, because many people, especially young students, are not that fluent in English. And as you have mentioned, there are very big differences if I ask a question in English or Hungarian. Is there anyone who is doing some benchmarking or research or insights on that? If I'm a Hungary, if I need to recommend a service to a student, probably high school or early university, which one is better in Hungarian for which tasks?
Okay, thank you. That's a really complex question. So we have to split two parts of those aspects. First one is which model to use. So there are multiple large language models. ChatGPT is by OpenAI, but there is Llama from Facebook or Meta. There are other models, DeepSeek from China as well, which are a bit different. Those are the underlying motor of of the answers that you get. Yes, and they have some structural differences as well. For example, ChatGPT is, as far as I know, a single model, but while DeepSeek is a mixture of experts. That means that it includes submodules for different tasks, and only a part of its parameters or weights are activated for answering your question. So there are such structural differences. And regarding your tasks, you can select among those models. For example, in GitHub Copilot, you can check or select which model you want to use for your tasks. For example, you can have ChatGPT's O1 Mini, or you can have Claude, for which is said to be better at coding tasks. And those are evaluated regularly, and those ranks are changing. So it's rapidly developing. We can tell that whether ChatGPT 3.5 was better than DeepSeek or not, but they are coming out with newer models, and the rankings are changing. There are some so-called standardized measurements. For example, István Csabai was talking about the last exam for humanity and things like that, which measure how well they mimic human reasoning and thoughts. But there are some other aspects. I have found reviews which evaluate their performance in coding. So how well structured, or whether the code is true that they generate. And concerning students in Hungarian, that's an interesting question, because these models get better and better. So somehow there is some transfer of knowledge from English to Hungarian, because they use a single embedding for different languages. So reasoning structures may come from English when they speak in Hungarian, but use of Hungarian language lags behind. There are some efforts by Gyöngyösi Blatabara, for example, to train a model for Hungarian language. I don't know whether those efforts will have a consequence because these large models, which are not for Hungarian, are getting better and better as well. So I don't know who will be first in this race. Thank you for your question.
Further questions to Marci? Very good.
Oh, thanks. Thanks for a nice introduction. I have a more principled than technical question here. I mean, we are encouraged as a research community to use AI tools, but most of them are, okay, they provide some free service which uses the previous model, is limited and so on. But to real harvest the power, we should use the real stuff. So is there some institutional account, some support, some subscription, or is it expected that everyone should have individual subscriptions to use this?
That's a really good question. If I understand well, then you are asking whether there is a unique subscription you can use for all of the models, right?
Yeah, I mean, it's a Hundren strategy to use AI models. Then is it supported in a way that institutional subscription or not?
Yes.
T3 chat, I think, page is there for €8 per month, and you have almost. Yes, I can show you, but that T3 chat, T3.chat, I think it's the one that really nice, €8 per month, and you have almost.
Okay. Okay, let me try to answer that question. I'm not a representative of the directorship of Hanren, so I'm giving you my opinion only. There are a lot of models, and in this AI for Science program, Hanren decided to spend money wisely. We can criticize them for that, but they want to spend money wisely, so they are doing all the effort possible. So they are providing us with the free tools within the house when that's enough for you, that's great. And they are trying to do some subscriptions, but they realized that giving you a subscription for all of the possible services, for example, Research Rabbit, SciSpace, ChatGPT, whatever you find on the net, I have a list of about 80 of them. For each and every of the researchers would cost just too much. So there is, it's wiser to have some subscription based on usage, and the OpenAI credits are for such a thing. And there are some agreements being done for SciSpace as well. So if you have a specific use case, then ask your AI ambassador to talk about it to the program organizers, that it would be really important to include that subscription and what kind of subscriptions are available, which can be transferred. So if, for example, if I'm writing a paper for 3 months and then doing research for 9 months, then that it would be advisable to transfer that subscription for writing to someone who uses it on that time scale. So it's a complicated question. Currently, we do not have a lot of paid subscriptions.
Okay, Marty, thank you very much. I think we should stop here. I just want to make one tiny remark with respect to this Search Rabbit and others, that we had this project in a very early phase between around 2015 together with CERN, which was called Collaboration Spotting. So I think maybe I can state I not confirmed, but we were one of the ones who developed this, the baselines of these things. So it's time for coffee. So thank you all of the speakers, especially Marci as last speaker. And